Good morning. We will be doing indicator 12.2 today. And so I've prepared some notes for you in the video. You will need to get out your 3-ring binder and make sure that you are taking notes in your binder so that you're ready for note check later on in the week. And also your notes will help you with your homework assignment, which when you're done with this video, you open up or go to the back to the assignment in Canvas and click the load button. It'll load the assignment in Cami, and then you can complete your assignment in Cami and then submit it to me so that I can grade it from home. All right, so some of this is review. I'm only going to do one example of the reviews, and then some of this is new material. On the review part, you don't have to put it in your notes for 12.2. I'll let you know when we get to something new that you do need to actually put in your notes. All right, so this is a review from yesterday. So it says determine if the following relations are functions, then state the domain and the range. So is it a function? Well, we look for repeating x's, and we see that we do have a repeating x. So no, this is not a function, and it's not a function because of right here, this x equals 1. Okay, that's our repeating x. All right, so now we need to state the domain and range. Now remember, when you're given the information in or you're given the relation as just a set of points, you're just simply going to list the x's and then list the y's from lowest value to highest value. So the smallest x that we have here, let me make this a little bit bigger. So I'm just looking at my x's here. So if I look at just my x's, right, I have 1, -2, -1, and 1. So my smallest x value here is -2. Then next is -1. And then next is 1. Now, again, there's 2 1s, but we only have to list it once. So that is the domain. And then the range, you can also, if you feel like it's easier, sometimes I think it is easier to fill in this domain and range with a text box. So if we're going to do that, then we would just put the text box here, and we would do, right, our fancy brackets. And then if you look at our, excuse me, if you look at our y's, right, we've got a -2, get a different color here, there we go. So for our y's, we have a -2, a 0, a 2, and a 3. So our smallest value first. And so the smallest value of our y's is -2. So we put -2. And then the next value would be 0. And the next value would be the 2. And then the 3. And that is a list of all of our y values or our range. So you've got no, it's not a function because of x equals -1, a list of your x's, -2, -1, and then of course there's 2 1s, but you only have to list it once, and then your range is -2, 0, 2, and 3. Okay, that is a review. Excuse me. That is a review from yesterday. Okay, next, this is also a review, right? It says, write each of the following as a relation, state the domain and range, then determine if it is a function. So if we remember back to day 1 of indicator 11, we defined what a relation is, and a relation is simply a list of ordered pairs that all are in a relation together. So we start out with our fancy brackets, and then we start listing each xy value. And so the first one is at -2, -2. So -2, -2. Okay, that is, and I will try to help point to which one I'm doing each time. So that is this point right here. That's the point -2, -2. Next in my relation, this is a -1 and this is a +1. So this point is -1, 1, right? That's that point. So I'm going to put that in my list of relations here. So -1, 1 is a point on my graph. And then next we have this point right here, which is the point 1, 0. So 1, 0. And then next we have the point right here, which is 1, 1. So 1, 1. And next we have, doesn't matter which one we do first. So we've got the point 1, 2, 3. So 3, negative 2 is a point. So 3, negative 2. And then last is this point up here, which is the point 3, 3. All right, so I have listed my relation, okay? Oops. There we go. So there is my relation, which is just simply listing out all the points. Now I need to state my domain. And so my domain is all of my x values from smallest to largest. So negative 2, negative 1, 1, which is on there twice, so I only have to list it once, and then 3, which is on there twice, and I only have to list it once. So there's all my x's. Now I can already tell because I had repeating x's, so I'm just going to go ahead and fill this out. No, it is not a function because of, well, you can pick. It doesn't matter. It can either be because of the ones, right? You're repeating ones, or you're repeating threes. It doesn't matter which one you pick. And now we need to list our range. So we give ourselves the brackets here, and now we list all of our y values. So I've got negative 2. It's in there twice, but we only have to list it once, right? It's there, and it's also there. Next is 0. And then we have a 1, which that's on there twice, but we only have to list it once. And let's see, negative 2, 1, oh, and a 3. So the very last one there is a 3. And then we close up our brackets. So if you look and see, you've got your relation, which is your big long list of all the points in your graph. Then our domain is just our x's with no repeating ones. Our y is just our y's with no repeating ones, meaning that we don't type the same number in there twice. And then is it a function? No, it's not a function because we had repeating x's in either the x of 1 and on the x of 3. And if you notice our vertical line test, right, it fails it at x is 3 and it fails it at x is 1. All right, so next we have something that, sorry, you guys have not really, you've seen it, but you've not actually constructed this before. So we are going to map out our points. So remember that our x's, right, go here, and our y's, let's see, there we go. All right, so remember that we've got our x's and our y's. We're going to map this. So the first thing I'm going to do is I'm going to list all of my x's in the x map. So my x's, right, are right here, and I'm going to list them in order. And remember, since I have a repeating negative 2, I'm only going to put it in there once. So negative 2 only goes in there once in my map, and then 0, and then 5. Okay, so that is all of my x's. Now, my y's go in the y bubble. So my y's, I have a negative 1, I have a 3 and a 4, and then I have another 3, but I only put it in the map once. So now I connect. Right, so I'm going to take a line and I'm going to connect each point. So negative 2, negative 1. So negative 2 to negative 1, 0 to 3, 0 to 3, 5 to 4, 5 to 4, and then negative 2 to 3, negative 2 to 3. Now I have mapped each one of my points, right? If I have 4 points, I should have 4 lines going down the middle. And then I state my domain. Well, this is your domain. You've already mapped it out. It's already right there. So all you have to do is get you a text box, and your domain is, right, negative 2, 0, 5. You already found it, okay? Your range is what's in your range bubble, okay? So your range is negative 1, 3, and 4, okay? That's our range. And then is it a function? Well, do we have a cheating x? Well, we can see, whoops, get a text bubble there. No, it is not a function. And the reason it's not a function is because, right, oops, right here, right, that's our cheating x because he's going out to two different y's. So no, it is not a function. Why is it not a function? It is not a function because of x equals -2. That's our one that repeats, or the one that goes out in our map to two different y's. So another example, so you're going to want to put these two in your notes. So if you need to pause the video right now to put these in your notes, you should do that. Oops, I accidentally deleted one of my lines here, -2 to -1, that was a line. So because this is new material, this is the first thing that you want to put in your 12.2 notes for today. All right, let's look at another example here. So we have again, right, we've got our, excuse me. All right, we've got our x's and we have our, keep losing my colors here, my y. Okay, my x's and my y's. So in my x bubble, I'm going to list my x's that I have. So my x's, I have a -3, and you can use a text box if you want it to for this, that's fine. A -3, a 3, a 4, and a 6, right? A -3, a 3, a 4, and a 6. Those are my x's. Now I look at my y's, and I have a 2 and a 4, right? A 2 repeats, don't need to put it in there twice. A 4 repeats, don't need to put it in there twice. But I do need to draw my lines. So I look at each point one at a time. So 3, 2, the point 3, 2, so it connects 3 to 2. Then I look at the point 4, 4, and it connects 4, 4. Then I look at the point 6, 2, and that goes up here to 6, 2. And then I look at the point -3, 4, and -3, 4 connects like this. So again, right, your domain is already basically done for you once you have done your mapping. So your domain, whoops, let's make that a different color. There we go. Your domain is -3, 3, 4, and 6. Move that up a little bit. There we go. And our range, again, you've already done the work. You've done your mapping bubble here. So we know that our range is 2 and 4. And then is it a function? Well, we've got all of our x's only have one match. So yes, it is a function. Okay, so again, this is the first thing you're going to have in your 12.2 notes because this is the first new item from today. All right, so now let's scroll up. This is a review. You do not need to put this part in your notes, okay? We did this yesterday. When you're given a graph and you're asked the domain and range and you're actually given a graph that you can see, you got to think walls, floor, and ceiling, all right? So our walls here, or our side, whoops, excuse me. There we go. Our side wall here is at, it's kind of hard to see, but that's -5. And it's a closed bubble, so that is a hard bracket at -5. And then our other wall over here is also closed, and it is at 7. So 7, and it is a closed bubble, so it's a hard bracket. Then when you go down to your range, right, you're looking at your floor, which is right here at -9, and it is a closed bubble, so it's a hard bracket, -9. And then my ceiling goes all the way up here to +9. And again, it touches +9, and it's a closed point, so it is a hard bracket. Is this a function? Does it pass the vertical line test? Yes, it does pass the vertical line test, so it is a function. Okay. Number 15 here is another example of when you're given a graph and you're asked for the domain and range. Think house, walls, ceiling, floor. Okay, so I'm going to look at first, I'm going to look at my side wall here. and that is at -10, and it is an open circle, so that is a soft bubble at -10. And then I look over here, and at +10, it is a closed circle, so at +10, that would be a hard bracket. And then if you look at your range, our floor here is at -5, and it does touch -5, so that would be a hard bracket at -5. And then our upper line is here at +5, and it's a closed circle at +5, so again, that would be a hard bracket. And then is this a function? Yes, it does pass the vertical line test, so that would be a function. All right, so that's a review from yesterday. This part is new, so you're going to want to put a couple of these in your notes, okay? At least I'd say probably the first several that we do, and I'll point out some that are different. So you'll notice what's different about these is these now have open circles, closed circles, and arrows. And you're also going to express these as an inequality notation, okay? And in your homework, you're going to know it's an inequality notation because on each row, you're going to have something that looks like this. And I've already got it on your homework, so you do not have to put it there, okay? All right, it is going to look like this, okay? It's an inequality with a D in the middle, which means domain. And basically what you're going to put is remember, domain is the sidewalls. So you're going to put the sidewalls. Now, if you'll notice, right, this arrow means that this line continues to extend forever and ever and ever and ever and ever this way, okay? So I'm going to do first the domain. So it continues to go forever and ever and ever, which means does it have a sidewall where it stops going left, right? It's going to continue to slant left and upward. So it's going to, because of the arrow, it's going to continue for infinity to the left. So on the left side wall, you're going to put the infinity sign. Now on the right side wall, you have a closed circle. So that means it stops right at 4. Now with the inequality notation, again, you're going to know that I want inequality notation because on your homework there's already this less than D less than, okay? And for your range, it's going to look like this. Let's go text box and put that in there. So for your range ones already on your homework, okay, it's going to look like this, and then that. Okay, so this is what it's going to look like on your range. I think I have it all in black on your homework, but that's fine. Same thing, right? So this means I want it in inequality notation, which means you're not going to use hard and soft brackets. You're just simply going to put how far does it go on the left, right? And then for your range, how far down is it going to go and how far up is it going to go? Well, we have a closed circle, which means a stop, right? So if we look at our bottom or the floor of our equation, our floor is at -5. So our floor is at -5. Now, if you look at our ceiling, do we have a ceiling? No, because what happens? It keeps pushing through. So it goes to infinity. And actually, I forgot something right here. It's -infinity on the domain because it goes backwards to the left forever and ever. Okay, so it's -infinity, meaning it's going to go backwards further and further and further this way forever and ever and ever, -infinity. Okay, the range infinity is a positive infinity because it's be going up, up, and up forever. Okay, and then is it a function? Yes, because it passes the vertical line test. Okay, so let's look at the domain of this second example here. So if we have, right, and I'm just going to write it on here now, but on your homework, I already have it typed in, this greater than D greater than, or less than D less than. So for our domain on number 2, let's look at our left side wall. Well, there's a definite stop at -5, right? And on inequalities, you don't worry about open circle, closed circle. Both of those mean stop. The arrow means infinity. So I have a stop on my left, which means I stop at -5. And then this will already be on your homework, so you don't have to worry about that. And then my right, think about what the arrow means, right? It's going to keep going positive infinity forever, all right? It's going to keep, I'm running out of room here. It's going to keep going positive infinity forever. It's not going to let me write it just because I'm right on the edge there. There we go. Positive infinity forever, because it's going to keep going to the right for an ever, ever, and ever. Okay. Now let's look at our range. Well, our range, first we need to look at a floor. Well, do we have a floor? No, because what happens, right? We keep going negative infinity or down forever and ever and ever. And then what's our ceiling do? Well, our ceiling has a definite stop at 2. So if it is a closed or an open circle, it's a definite stop with a number. If it is an arrow, it's either going to be a positive infinity or a negative infinity. Okay, let's look at number 3 here. So our domain is wall to wall. Well, can we wall in either side? Well, if we try to wall in this side, this keeps going forever. If we try to wall in this side, this keeps going forever. So our domain doesn't have a left and a right. It goes from negative infinity to positive infinity because there's arrows going both ways, left and right, forever and ever. Now, if we look at our range, okay, what's our floor do? Well, our floor definitely has a stop, right? It stops at -3. This is our range. And what's it do going up? Well, can we put a ceiling on it? Nope, those arrows bust right through it, so it goes up to infinity. Okay, number 4, can we do sidewalls here? Absolutely, right? It definitely has a stop at 1. And does it have a stop on this side? Definitely it has a stop because those circles, open or closed, mean stop at 5. Now let's look at our range. Well, let's look at our floor. Our floor is -4. This is our range. And then our ceiling has a definite stop at +4. So that one doesn't have any infinities, but it shouldn't because there are no arrows on the graph. So if you have arrows on the graph, you're going to have some infinity somewhere on your graph. If you have no arrows on your graph, then you're not going to have any infinities in your answer. Okay? All right, so let's look at this one. We have domain. So we look at this side. That is a definite stop at -5. And then on this side, we don't have a definite stop, right? Because that arrow just blasts right through that wall, so it goes on and on for infinity. I know my infinity signs are sad, but that's okay. Now let's look at my range. Do I have a downward stop? Definitely, right? My downward stop definitely is at 0. And then do I have an upward stop? Nope. This is going to keep going forever and ever and ever for infinity. Okay. Let's look at the domain for number 6. And again, if you need to, pause the video, take time to look at my answer, look at the graph, and figure out where I got the answer I got. So my domain, I definitely have a stop at x equals 0. This is my domain. And do I have a stop on the right? No, those arrows will bust through, right? No matter if I try to put a wall here, it's going to bust through and go for infinity. For my range, right, can I put a floor on this? Well, no, because I'm going to keep going and bust right through that floor. So I'm going to keep going down forever, so I have a negative infinity for my range. And then can I put a ceiling on this? Again, no, because it's going to bust right through that forever and ever, so I have positive infinity. So for my domain, it's 0 infinity. For my range, it's negative infinity to infinity. Okay, meaning that there is no floor and there is no ceiling because it just keeps going forever. And then this one that you can see here, it has arrows on both sides, straight line. So what's my domain going to do? Left and right, what's it going to do? It is going to go on forever and ever left and forever and ever right. So it's going to go on from negative infinity to infinity. And then my range, again, can I put a floor and a ceiling on this? No, it's going to keep going high, low forever and ever. So my range is also negative infinity. This is my range to infinity. Okay, so a diagonal line with an arrow on both ends is always going to give you all for infinity. All right. So that is the last bit of new that I have for you today. If you have any questions, please don't hesitate to email me. If you have a question that can't be answered through email, we can open up the Google Meet from Monday, and I can jump on there and I can answer your question as well on the Google Meet. So go ahead and click load on the homework assignment. It'll pull it up in Kami. Again, you can use text box if that's easier. It would probably be a whole lot neater to use the text box rather than the pen tool, but whatever works for you in order to answer the questions on your homework. Okay, let me know if you have any questions, and I will post Wednesday's e-learning assignment on Wednesday morning, and then hopefully I will see you all on Thursday. Talk to you soon.